So the next topic we're going to cover is continuing on with our discussion of the internals of Java parallel streams. We're going to focus in more detail on the partitioning phase. If you recall before, we talked about how there's the split, apply, combine paradigm for parallel computing with Java streams, parallel streams. And we're going to talk more about the split phase using splitterators, in particular parallel splitterators. So we've talked about this a bit before, but we're going to go into more detail now. So a splitterator is something called a portmanteau, which is a combination of words that means splittable iterator, that partitions the Java parallel stream up into chunks. And we've seen earlier, when we talked about sequential streams, how the splitterator can be used to traverse elements in a source. So if we have this famous quote from Shakespeare's Hamlet, you can make a splitterator for it, and you can walk through this thing one phrase at a time, one chunk at a time, this above all, one word at a time, I guess is a better way to put it, and print the results out. We're now going to talk about how we can use a parallel splitterator to partition the elements in a source rather than traverse them. And of course, the way this is going to work is we're going to come up with a way to take some immediate and large data source, like a list of strings, and then split it up into smaller chunks until we end up with atomic size units, which would be strings, a list of an element of one string. And the way this is done is through the trySplit method that's defined on list. Now, we'll talk later about the different ways of doing this. There's the ArrayList way of doing things. There's the LinkedList way of doing things. There's other lists, but we're going to focus here on the basic concept. And the way this happens is the streams framework calls the splitterator's trySplit method. The user doesn't call this. It's done by the framework, and I'll actually show you in just a bit how this actually works in the implementation code of Java streams. So when trySplit is called by the framework, what it's going to do is it's going to try to split the input up, ideally evenly, especially if it's using an array list, because it works quite nicely because it's easy to figure out where the midpoint is with very quick computation. And if there's if there's something to be split, in other words, if you haven't reached the minimum size, it's going to split it up into two even-sized chunks. And then it's going to return a splitterator for the left chunk, and it's going to leave the right chunk to be worked on in the calling thread. And a splitterator typically doesn't need any synchronization, and it doesn't need to worry about joining. That's all handled by other parts of the streams framework, so you don't have to worry about locking, which is nice. The trySplit method is called by the framework until all the chunks are less than or equal to the minimum size, which in this case is typically 1. So it's hard to split things more than 1. So 1 is the smallest size for something like a list. And when you get down to something that's size 1, a null is returned, and that's an indication to the framework that it's finished, and now it should go ahead and do something with what it's been working on. So trySplit will finish when the size of the chunk is less than or equal to the minimum size, in which case it returns null. When it returns null, the stream framework then takes whatever's left, which is typically one element, and it processes this chunk sequentially. So we'll look at that code when we get to that. Let's take a look at a couple of examples. This is the example from ArrayList. You can get the ArrayList code here in an open source manner on the web. And here's the try-advance and the try-split methods. And this is pretty cool because what you can see here is that what try-split does is it figures out what the midpoint is in the array, because that's easy to figure out in the array list, because you take the high and the low. So let's say it starts with 0 and size, plus 1, or size. You add those two things together. You right shift by 1, which is like dividing by 2, but just arguably a little faster. I have a feeling it's no longer any faster with modern Java compilers. And that gives you the midpoint. And then we go ahead and we split things in half. So the ArrayList splitterator returns a new splitterator that covers the left-hand side, which is from the low to the mid. And then the right-hand side just updates the low to be mid. So now mid is going to be the right-hand side. So now we've split things in half. We return that. So the point of this is that ArrayList split things up very easily and quickly and evenly. And then try-consume is used to consume something when you've split it all up to an atomic size unit, say of size 1. And you can see what that does is that goes ahead and it accepts the list element at index sub I into the consumer that's passed as a parameter. And assuming all goes well, which it should, it'll return true. So that's the way that ArrayList works. Let's take a look at LinkedList by contrast, which is a little different. So you can see with ArrayList, it splits it evenly and efficiently. You end up with two roughly even-sized halves. With LinkedList, however, it doesn't work this way. What it does instead is it will go ahead and split the list up into batches, and the batches have a certain size. And it doesn't try to split it in half, because that would require going down through the entire linked list, following all the links till you reach the quote midpoint, and then doing it that way. So they don't even try that. Instead, they split things up into batches, and they copy the data. So you can see that they're copying the data. And then they go ahead and they call a splitterator on that piece there. The try-advance method is also a little bit more complicated because it's a linked list, not an array. So we have to do a little bit of fancy footwork with respect to following pointers and so on to get the item and accepting that into the consumer. So we might expect, and we'll see this in the next lesson or two where we actually run through the code and see how well it works, we're going to see how the difference is between these different approaches when they're used on actual data in a parallel stream. So we're going to take a look at parallel splitterators in the upcoming examples. And I'll also show you how to write a parallel splitterator, because that's kind of interesting as well. OK, so that's the end of the more detailed discussion of partitioning for parallel streams. The key thing to remember is that it tries to split, the streams framework splits until we have atomic size elements. And at that point, it then goes ahead and will consume each of those elements and then eventually assemble everything back together again by combining it in the combined phase. But that's not the splitterator's responsibility. It's just doing the splitting.